All right, let's talk about the internet. I mean, we use it every single day, right? But have you ever really stopped to think about how it all works? And I'm not talking about the websites you visit. I'm talking about the deep, invisible infrastructure that connects all of us. So today, we're going to pull back the curtain, demystify the magic, and find out how the internet actually works.
Think about it. You're using it this very second. But if someone asked you to explain it, could you? What is this thing really? This invisible force that connects us to, well, pretty much everything and everyone. Let's break it down.
Okay, so at its core, the internet is actually surprisingly physical. Yeah, it's not some magical cloud floating up in the sky. It's a real, tangible global network of computers. They're all physically wired together, talking to each other. And that simple, powerful idea, that's what everything else is built on. So the big question is, how do you even begin to build a global network? Well, you start small. You have to. Let's zoom all the way in and start with the absolute smallest, most basic network you can possibly imagine. Look at that. It's just two computers connected by a single cable. That's it. This right here, this is like the basic building block, the DNA of the entire internet. But okay, what happens when you want to add a third computer or a 10th? This is where things start to get interesting and a little messy. Okay, so let's try to scale this up. But we're not talking billions of devices yet, not even close. Let's just try to connect 10 computers. Now, if you wanted every single one of those computers to have its own direct private cable to every other computer, how many cables would you need? Just take a guess. 45? Yeah, you need a whopping 45 separate cables. It's wild, right? And get this, if you add just one more computer to the mix, an 11th one, you'd need 10 more cables. The complexity just explodes. It's not just messy, it's a total nightmare. But luckily, the solution to this chaos is actually pretty elegant, and it's a huge piece of this puzzle. So yeah, obviously, this direct connection thing is a recipe for disaster. This whole problem of how do we connect a bunch of computers without creating a monster out of cables led to a really brilliant invention. And I'm willing to bet you have one in your home right now.
Right. So instead of that cable nightmare, all the computers plug into one central box, a switch. The best way to think of it is like a smart traffic cop just for your local network. When a message comes in, the switch looks at where it's supposed to go and sends it only to that specific destination. It's simple, it's clean, and it's super efficient.
Okay, so a switch is perfect for a local network, right? Like in your house or in an office. But the internet, it's global. So how do we connect our little local network here to another network, say on the complete opposite side of the planet? Well, that is the next big challenge. So a switch is great for handling traffic inside its own little bubble, but it has no idea how to get a message to the outside world. To do that, to connect our network to other networks, we need a different piece of hardware. And that device is called a router. A router is like the post office for your network's data. It reads the address on a message and figures out the best way to send it out to a different network. So a switch manages traffic inside the network, and a router connects your network to the outside world. It's your gateway to the global internet. So let's trace the path of your data, just for a second. It all starts on your computer. You send a message, and your modem translates it so it can travel over the phone or cable lines. Then it hits your internet service provider, your ISP. Think of your ISP as your personal on-ramp to the massive internet highway. They take your data and use their huge network of routers to send it speeding across the country or even the world until it finally arrives at its destination. And really, that's what the internet is. It's a network of networks. It's not one single thing controlled by one company. It's this massive, sprawling global collaboration of all these different ISP networks, all connected together. It's kind of chaotic, but it's an incredibly powerful system. Okay, so we've got the physical infrastructure down, this giant web of connected networks. But how does anything find its way around? I mean, how does your email find the exact right computer out of billions? Well, for that, the internet needs an address book. Seriously, think about it. With billions and billions of devices connected, how does your data find the one specific computer it's looking for? It's like trying to find one specific house in the entire world without an address. It's impossible. Every single device needs a unique address to be found.
And they have one. It's called an IP address. It's that string of numbers you see. Think of it like a unique phone number for every single device on the internet. But let's be honest, who wants to memorize a bunch of numbers like 142.250.190.78? Nobody. That's why we have domain names like google.com. They're just easy to remember nicknames.
Yup, a domain name is just a human-friendly nickname for a hard-to-remember IP address. So when you type google.com into your browser, your computer instantly looks it up in the internet's giant address book, finds the matching IP address, and connects you. It all happens in the blink of an eye, and it's what makes navigating the internet so easy.
All right, so we've covered the physical connections and the addressing system. But there's one last really important distinction we need to make, because it's something a lot of people get mixed up. And once you get this, the whole picture will be much, much clearer. So, the World Wide Web, is that the same thing as the internet? The answer is not exactly. We use the terms interchangeably all the time, but they're actually two different things. Here's the best way to think about it. The internet is the infrastructure. It's the network of roads. The World Wide Web, on the other hand, is a service that runs on that infrastructure. The web is all the cars, trucks, and buses that are driving on the roads. The roads are the internet. The web is just one type of traffic using those roads. And there are lots of other services using those same internet roads, right? Things like email, or when you're playing an online game, or streaming a video. All of those are just different kinds of traffic on that same internet highway. The World Wide Web, the thing with all the websites we visit in our browsers, it's just the most famous one. It's pretty amazing when you think about it. This whole thing started back in the 1960s as a US military research project. And now, well, now it's completely transformed our world. It's really a story of solving one problem after another on a massive scale. But that story isn't over. The internet is always evolving. So the real question is, what will the next 60 years of connection even look like?